Hello students, let's study about Coulomb's law, 12th standard physics. So first of all, in Coulomb's law, what we are going to study is first a basic concept of Coulomb's and derivation and the Coulomb's law. So we have two types, that is vector form of Coulomb's law and application of Coulomb's law. So first of all, let us consider force. Force, always force will be always between one end to the other end. It's a force between charges. Now, we are speaking purely about the charges. Charges, we have studied earlier classes, that is a like and unlike charges. You know that like charges will be a positive positive or a negative negative, which will repel. That is, we have earlier told that both repel each other, that is like charges. But in physics, when you come to the subject of 12th standard, we speak as repulsive force. At the same time, when we come for the unlike charges, they attract, everybody knows, that is plus or minus or vice versa, minus or plus. But here also it experiences the attractive force. This is a main basic what you have to think about under the Coulomb's law, that is it's regarding the forces which is between the two charges, that is a positive positive or negative negative or positive. Those are the two charges. So here first of all, Coulomb's law can calculate the force of attraction repulsion. So here we told both force repulsive and attraction. That same thing, force attraction or repulsion between two charges, that is plus plus minus plus whatever. So this was given by French scientist called Coulomb. So earlier in classes in primary also you might have studied, that mass means it's a kg. The measurement how we used to take is mass, in the sense measurement is kg, that is 10 kg apple we call it as. But here the charges we call it as Coulomb. So another name what we call in the charges, instead of charges we call it as Coulomb. So Coulomb is nothing but it's a product of magnitude of charge between two charges. So one end to the other end, 0.5 C into 0.3 C. We multiply magnitude of two charges. So first of all, we'll come to this. So Q1, we are taking here two charges. One is Q1, Q2. You can take P1, P2, whatever it is there, but have taken as Q1, Q2. Here it is, both are positive. And from one end it starts and ends the other end. So in between the distance what we call it as R. So between the distance between Q1 and Q2, the force we call it as a distance and we represent it as R. That is a size. What is the size between Q1 and Q2 only we are going to find now. So how much force is these two? So what are the force? What speed it is going from one end to? This is what we are going to find out in future. So first of all, F is nothing but a force. So here the force pulls left side, here the force pulls on the right hand side. And between what we are getting, that will be your R sizes. So first of all, we know that force is directly proportional to Q1 and Q2. That is a one equation, it's a directly proportional. So another way of studying is force is inversely proportional. Inversely proportional in the sense 1 by R. So even this also you might have studied inverse proportion. So if you combine both the equation, direct proportion and inverse proportions, you write it as F is directly proportional Q1, Q2 by inverse will be a R2. So now instead of writing this proportional symbol, alpha symbol, we are going to write it as K. K is nothing but it's a constant. So F is equal to K, Q1, Q2 by R2. That's a Coulomb's law. So here K, it's a Coulomb's constant. So first of all, Coulomb's law depends on three factors. One is F is directly proportional to Q1, Q2. The second one, it is inversely proportional. And third will be your value of K, what I told, that will be your constant. Coming here for K, here we call on a vacuum, air or vacuum, it will be 1 by 4 pi 0. So K is equal to 9 into 10 to the power of 9. So Nm we call it as Newton meter square per coulombs square. So this is what the important points you have to remember. Coming now important points where in the Coulomb force acting on charges, you know, first of all the dotted points starts from plus and it's a negative. So this will be your unlike charges. So if it acts a line joining the center of charge, this is one point. The other one is why we call Coulomb's law, because it is inversely square law. So force between two charges, inverse law in the sense, suppose if I increase, it increases by 2, it decreases by double, it's 4. If it is increasing by 3, here it decreases by 6. This is what inversely proportional you have to understand. Coming to point charges, here you know the charges should look like a point. From larger distance, point does not mean small charge. If it is looking like a dot dot dot, it's not that it is a smaller one. So for example, if I can give you, if you see the stars in the sky, it looks very tiny, but it's very huge and large. But what is the reason is, we are far from the sky. This is how you have to call it as. Under Coulomb's law, vector form of Coulomb. You know, first of all, I told two charges, that is Q1, Q2 will be there. When you force that side, it will be F21 and this one will be your F12. So if I take F force on Q1, Q2, so if I take this, so the force is coming from here to then it's going there. So starts from here. So you have to take 2, that is Q2 by Q1. So if you are going to take R2 in the R12 is a distance. You have to, again it starts from Q1 to Q2. So if you are going to take F21, where I told instead of proportional you have to put K constant, then Q1, Q2 by R2. So this is what you can understand. Okay, F12 force by Q, again R same thing, displacement, Q2 Q1 and if F12 Q1 Q2 by R2. So same thing inversely also I have told you same thing. This is also same thing, 21 is equal to minus. These two charges extend equal and opposite forces. An example, if I take application of Coulomb's law. Suppose a positive charge, if they have given 3 into 10 to the power of minus 6, C will be your Coulomb, is 0.2 meter. M is already mentioned, meter, from the second positive charge, means on the right hand side. First charge is this, second charge is this. That will be 5 into 10 to the power of minus 6. This is also Coulomb. They have asked, you have to find out the force. When they have asked to find out the force, automatically you know the formula what you have to apply. Force is equal to K will be a constant, Q1, Q2 by R2. So here first substitute everything. So Q1 will be your one charge on the left hand side, Coulomb. 3 into 10 to the power of minus 6 Coulomb. Q2 will be on the other sides, that is on the right hand side, 5 into 10 to the power of minus 6C. So R will be your distance between both. That is what it is, 0.2 m they have already mentioned. Now substitute to this formula. You know already K is equal to 9 to the 10 to the power of 9. Okay, which will be a constant. And Q1 will be 3 into 10 to the power of minus 6 and Q2 will be 5 into 10 to the power of. When you multiply all this and divide by R, you are going to get a force as F 337.15 N. So, okay students, if any doubts, please you can comment on this. Thank you for watching.